Sir, please wait 5 minutes for joining participants.
Sure. Sure, India.
Thank you, sir. Oh. Good evening, everyone. A very warm welcome to the AI Community Talk organized by the IEEE Student Branch of University of Kelaniya in collaboration with AI-Driven Sri Lanka, an initiative by IEEE Young Professionals Sri Lanka. Today, we would like to explore the concept of MCPS, the future of AI interoperability. As we look to the future, MCPS will play a key role in areas like smart cities, healthcare, manufacturing, and more, making AI more powerful, more connected, and more useful in our everyday lives. Let's dive deeper into these exciting ideas with the most suitable expert. So, let's move into the highlight of today's session. I am delighted to introduce our guest speaker for this evening, Mr. Ashan Priyadarshana. He is a tech lead AI/ML at Cisco Labs. With his strong background in AI and ML, Mr. Ashan brings valuable insights from both research and industry. His work focuses on developing intelligent systems that solve real-world problems. We are truly honored to have him with us to explore MCPS, the future of AI interoperability. Dear sir, the virtual stage is yours.
All right. Thank you, India, for that warm welcome. Um, yeah, let me share my screen first. All right. Hope all of you can see my screen. So if there are any questions along the way, I'd like to get them. I mean, just open your mics and ask them straight away. Um, so yeah, as Vinda mentioned, so we are going to talk about MCPs. Um, And now all of you know, before I dive into the topic, so now you know that AI is becoming a boom, right? So everybody is talking about AI, ChatGPT, everything. So after 2022 December, or we could say that since 2023, the AI became a boom, and the whole industry, not only the IT industry, the whole industries everywhere in the world is getting affected due to this AI. Now, this boom is going to get uh, increased due to this concept of MCPs. Now, with the arrival of the concept of MCP, everything, even before the AI boom, the systems or the things that were developed even before AI technology are now going to be capable of interacting with AI. So, for an example, let's assume there is a particular application, an old application or an old website, something like that. It does not know about AI. But now with this MCP technology, or we say it actually as a protocol, with this, now all of these old systems can interact with AIs, or particularly AI agents, very easily. So that's why everybody is talking about MCP. For an example, if you looked had a look around last week's keynotes, the special keynotes given by Google, Microsoft, even Meta, all of those founders, all of those CTOs, CEOs, they talk this word MCP. So if they talk around five sentences, for that every five sentence, this MCP word was there. So that's how powerful this MCP concept and MCP protocol is, because they know with this technology we can uh, provide all the old systems and even the new systems to the AI. So if there is an AI system, But if it wants to use an old website or old device, something like that, with this MCP, now this AI agents or any AI application can easily use those things, right? So that's why this interoperability comes in, the word interoperability, right? So the future of AI interoperability. That means with due to the MCP, now all the systems around the world can interact with AI agents. Right? That's the power of MCP. All right. Before going into MCPs, you need to first have an idea about agents, right? I'm pretty sure all of you have heard about agents. Uh, I mean, is there anybody who would like to have a thought on what an agent is, as you might think what an agent is based on your understand? Anybody who would like to give an idea? Okay, I think an agent is something like this, or according to me, an AI agent is someone like this. Any idea? I'll give maybe a couple of seconds if anybody wants to share their thoughts. All right. If no, I'll keep on talking, but feel free to don't be shy. Just provide your thoughts, right? So the best example that I would give for an agent is a pet in your home, right? For an example, let's take a dog in your home. I assume at least everyone here would have had a dog somewhere in their life, right? Or there may be dogs in your homes. Now, the best example why I take a dog for agents is that now dogs act autonomously, right? We don't want to tell a dog, okay, if an intruder comes in, uh, chase him away. We don't want to instruct him, right? He knows intuitively, okay, this person is not a friend of the home. I need to chase him away. Or if there's a snake or something like that comes into your residence, the dog chases away, or at least it barks, right? If something new comes into your home, it will bark, right? So we don't want to say specifically if there's a new strange face or if a strange thing happens, you should bark like that. We don't want to train it. It acts autonomously. That means it can think and act, right? That's the idea of agents, right? In traditional programming, so if we are to program something, we have to write each and every step for all the conditions, all the scenarios that could happen. But with agents, we just need to give him a rough goal, all right? Even when in the example of dogs, we just don't give any examples, right? It just acts. It's at night circles around the home. Uh, so if it's a friend, it will greet him. It will kind of smile or go and try to lick that person if it's a friend, right? So it knows who are friends and who are foes. Like that, it can act autonomously, and that's the concept of an agent, right? So with that concept in AI also, now we can develop agents, right? So with that basic idea, let's look at the basic example or basic definition of an AI agent when it comes to AI. So this is a very simple illustration that we can demonstrate the capabilities of agents. Now, assume there is an agent like this, some sort of a robot. Now, an agent can uh, observe the world, right? Its surrounding, its environment. It can observe the world. First, it will observe its surrounding, and we call it the observations or state, right? It will first observe, okay, what's my area, what's happening around me, something like that. it will observe. Based on these observations, so he will take these observations into his mind, and then it will do an action based on those observations, right? Now, for an example, dog will not bark if there's nothing suspicious. It will be just sleeping, right? So, if he observes the world and suddenly he see an unfamiliar face, then only he will take the action of barking, right? And then based on that, based due to this action, the world state will change, right? So if it barks, if it's assume it's a thief coming into your home, it will now go away. So that means the world state changed. Now there is no thief if you observe again. So first it will observe something, and they based on these observations, the agent will do some action. Due to that action, the world changes, the environment changes. Now in AI, when we are developing agents in AI, we are giving a reward to this agent. So if it did a good action, how we program our agent, how we build our agent is to give a good reward. Like for an example, when training our dog, let's say we are training our dog to give us the hand, right? So if he gives the hand, we might give him a small treat, maybe a biscuit or a bone, something like that. So if it does not give us the hand, then we will not give anything, or we will maybe scold him, right? So if this reward may be a positive reward, or it may be a negative reward as well. Now, based on the action, the world changes. Based on the changed world, is it a good change or is it a bad change? Based on that, we will give him either a positive reward or a negative reward. So that is the basic idea of an agent, right? Now, knowing about this agent is really important to understand about the MCPs, right? You will see that in a bit. All right. Now we can discuss agent in a deep manner like this. This is really going to help you to understand MCPs in the next slide, right? Now the same example is here. There is an action, and I mean this three steps can interchange, right? First, an agent can do an action randomly. Based on that, the world might change. Then new observations might come. Based on that, we can give him a positive reward or a negative reward. So all these things we can interchange, right? Especially these two. All right, now let's assume you are building an application or an AI system that suggests a song to users based on the mood, the temperature, and time of the day. Now, hopefully, I think most of you guys are university students, and maybe third year. Or I saw that review. The first year, there are so many first year students, there are second year students, and some are third year students, right? Now, in your universities, there are projects to do, right? Now, this is a good project if you can try, right? Building an AI agent that suggest songs based on the user's mood. So if you are building an application, some mobile application or a web application, something that suggests songs. Now it don't suggest songs randomly. It suggests songs intelligently, right? Now how do we devise that? How do we implement that? Now we first observe the mood of the user. We can get the mood of the user maybe using a camera, right? Based on the webcam or based on the way he interact with the mobile device. We can get those information. We can infer at least the mood of the user. And maybe we can look at the temperature of the user right now, right? If it's maybe too hot environment, maybe it may be a very cold one, something like that. And maybe we can get the time of the day, right? Now, based on these things, we can build an AI application which suggest a song, right? Now, for an example, when you are thinking about AI agents, we can easily conceptualize agents using this kind of a table. Now, I'm pretty sure going forward, you will hear this agent word so many times, right? You will hear AI agent, we are going to build these agents. Google may be saying, okay, we are building an agent, something like that. Whatever the whoever the person is speaking about this agent, you can conceptualize agent using this table. Just uh, imagine a table like this when someone talks about an agent. The table is very simple. There are states or these observations, right? Now we see that an agent observes the world, right? Agent observes the world. These possible observations are here, all the possible observations. And we say that an agent can do the actions, right? Whatever there are certain actions an agent can do. Those actions are these columns, the next columns. So there are mainly two parts in an agent table. There is the states that it observes from the world, and there are possible actions that an agent can do. Now, every agent can't do everything in the world, right? For an example, if we talk about a human agent, humans can't fly, right? There are a set of limited actions that an agent can do, right? A dog can't at least fly or speak. Those are not possible actions a dog can do. If we think about agents, a dog agent, right? So now there is these observations and these sections. Now we can think of these two things as a table. Now, in this example, an agent suggesting songs based on the user's mood and temperature and time. Now see possible states. Now mood can be he might be in a happy mood, and the temperature seems to be kind of cool, right? A cool temperature, maybe 20 degrees or 15 degrees Celsius. And the time is 10 a.m., right? Right now, the time is 10 a.m. In that case, now there are four possible actions. Now, there can this action is space can be huge, right? Hundreds of actions can be there. But for this example, I have only listed here four, right? Now, what are the possible actions that this agent can do? Okay, he can suggest energetic English songs, or he can maybe suggesting motivational songs. Maybe he is suggesting one of the sad love song, or maybe another action would be suggesting a calm love song. Maybe a sad love song or a calm love song or energetic English song, motivational song, something like that. Now, these are some four examples that this agent can suggest based on these mood, temperature, and time, right? Now, there is these set of values, right? Now, this is the thing that an agent actually learns. Now, if you are interested, you can actually build these kind of agents, which are very good research projects, good projects for your university time. Uh, that means, and these are the values that that agent has learned. So for an example, now here I just randomly inserted these values. According to this, in this case, the highest value is here. So if it is happy, cool, and 10 a.m., this agent might be suggesting an energetic English song, which is actually not which wrong, right? I just entered randomly numbers. Maybe based on the if it's happy, he is happy, cool, and it's in the morning. Maybe a calm love song, something like maybe suggesting in actual scenario, right? Now these values you have the agent will be learning. You can build systems to learn these values. The highest value, the action which has the highest value will be the suggested song, at least the category, like that. All right, now I think with that you have a good understanding about agents, right? So an agent has set of states that it can perceive from the world, right? Now, even with these three combinations, the mood, temperature, and time, there are so many states, the permutations or the combinations that we can have here is uh, maybe in thousands or 10,000s if we go into granular level, 10, 5, or if we consider the temperature in Celsius or something like that. So there are unlimited amount of state combinations in that this agent can think of, right? The state space is also so high, and based on the various zone categories or something like that, it's also going to be very high. But building such a system or an agent is very straightforward. It's something that you can do in your university level, right? A nice research project as well. So right now you know about the agents and when what to think about agents when you hear the word agent. Their actions, observations, and also through this reward function, actually these values will be get generated, right? Now I said that you have to learn these things. These are the things that will get generated when we are doing the learning part of this agent. Right? So then this reward function is used to generate these values. But those are things that you can look if you are to implement an AI agent. All right. Now, with this in mind, with knowing about agents, we can talk about MCPs, right? All right. Before looking into MCPs, have you heard about Claude Desktop? This tool, I think at least, if not at least, most of you may have seen. Now, this Claude Desktop is something like, let me show you actually. Uh, it's like ChatGPT. Uh, we can ask things, right? Okay, what is an AI agent? Now, it's like ChatGPT. It's here in my desktop, right? So yeah, it uses this cloud, and it's basically pretty similar to uh, ChatGPT, that kind of a interface. All right. Now I with that now why I showed Claude is it's a well good tool that you can practice these MCPs, the things that you are going to build today, right? All right. With that, let me show you a small video about Claude, the recent Claude things. Um, I'm not sure if you can hear, but can some of you can one at least tell me if you can hear this audio? Can someone please send a chat? The audio is audible or not?
No, sir.
You can hear, right?
No,
The
sir.
audio?
Not audible.
No, it's not audible. Still no, right? I just
N-
paused the video, but were you able to hear something?
No, sir.
No, all right, let me see. Uh, how about now? Did you hear something?
Yes, sir. Now
All right.
audible.
Okay, all right. Okay, let me play it from the beginning.
Hey, Claude, when's my first meeting?
I'll check your calendar. Your first appointment is Jenny's school drop-off at 7:45 a.m. After the school drop-off, you'll have some time before your first work meeting, which is the marketing team stand-up at 9:30 a.m.
Did I get an email from Bright & Co?
I'll check your Gmail. I see that you did receive an email from Bright & Co last night. In the email, they mentioned they're looking forward to today's presentation at 11 a.m. They also mentioned that their CEO.
Now here the scenario is the first this lady, she's brushing while she's brushing her teeth. She's asking
Hey,
something from
Claude,
Claude.
when's my first meeting?
Yeah, she asked about her first meeting, right? Now, if you ask that into a ChatGPT now, right? If you open ChatGPT and ask, okay, so hi, when's my first meeting? It does not know, right? Because it has no way of accessing your calendar or your meeting information. It just know how to maybe access internet. It maybe know all these learned things that the ChatGPT trained on, right? It does not know how to connect to a calendar or Gmail, right? Now
I'll
here
check your calendar.
it says that I'll check your calendar. That means this Claude system. Now assume this Claude as an agent, right? Now we talked about agents previously. Now what he is doing an action, right? I'll check your calendar. That means he is going to perform some action. Like this is synonymous to or similar to a dog doing some action, dog barking. This is an action. Now assume these everything's as agent. Okay, now he is going to say, "Oh, I'll check your calendar." That means he is going to do some action. All right.
Your first appointment is Jenny's school drop-off at
So he accessed your calendar and retrieved the information from the calendar. Now based on the calendar, it says that there is these things that you have to do today.
7:45 a.m. After the school drop-off, you'll have some time before your first work meeting, which is the marketing team stand-up at 9:30 a.m.
Did I get an email from Bright & Co?
I'll check your Gmail.
All right, now she asked, okay, did I get an email? Earlier, now she asked about the calendar, what are my time slots and everything. So then this cloud agent did an action and accessed her calendar and retrieved this information. Now she asked, okay, did I get some email? So for that, so today if you ask, okay, do I have new emails from ChatGPT? It does no, it don't know about it. It can't access your email, right?
I see that you did receive an email from Bright & Co last night. In the email, they mentioned they're looking forward to today's presentation at 11 a.m. They also mentioned that their CEO will be joining.
Now here that agent has accessed the mail and it looked through all the mails and found out, okay, an email which corresponds to the question that she asked. Now here it says that, okay, I access these your Gmail.
Joining the call, which wasn't originally planned.
Can you search my drive to see if Michael uploaded the pitch notes?
I've searched through your drive, but I'm not seeing anything that matches.
Okay, she asked, okay, can you access my Google Drive or something like that and see if there's anything that relevant to this meeting, something like that she asked. And then what this cloud agent did, so it performed another action. Agents are performing actions and observing things, right? Now all these things are happening. Earlier it did an action to access calendar and did observe that. Now always remember our previous example, the agent example, agent terminology, right? Agents are doing actions and observing continuously the environment. Now even here, up to now, this agent did 3 actions, and with those new 3 actions, it observed the world, right?
Would you like me to try different search terms? Or if you prefer, I can help draft a quick message to Michael about the presentation for your 11 a.m. meeting.
Okay, let's email Michael.
All right. Then she asked, okay, write an email. Again, another action, right? Now, based on those emails and the things about that this conversation, this agent now performs another action, which is writing an email, right? Always so think in terms of actions and observations. All right. Now all of these are possible due to MCP. Now, Claude is this Claude or the Anthropic, the developers of Claude are the Anthropic organization, right? They developed this MCP concept. They are the people who invented or introduced MCP protocol. So they extensively use this MCP. Now, not just them. Now it has become an standard of AI community, right? Throughout all the AI community, everybody is going to use MCPs to make AI or these chat interfaces or any AI application as agents, right? Now, because now we are seeing that agentic behavior, which is doing an action and getting the observations. So after doing some action, it will observe, or vice versa. It will first observe, and based on that observation, doing some action. So now with this MCP, we can build intelligent systems or AI systems which follows this agentic behavior, right? Any AI application or any chat interface or whatever the thing, now we can make them agents. That's the core idea. That's the basic idea behind this MCP. We can make any AI application into agents, right? Now, when it comes to now, let's look into MCP. So when we talk about MCP, there are three components that you need to know of. Main three components. Still, this is an agentic behavior, right? I'll match with our previous examples always. Now, we have, when we talk about MCPs, there is a component called host, there is a component called server, there's a component called client. So people say that, okay, we have to build an MCP server. People say that, okay, it's MCP client, like that. They are using these terms. All right. Now, assume this host part as ChatGPT-o, this Claude interface, this chat box, right? This one. Now, host is something like this application, Cloud desktop application. Or you can think of and host as our ChatGPT interface. Or we can think of host as our recent uh, our code editors. Even these code editors are now we can think of as host. Now you know that these kind of things are there, right? Um, Let me. Yes. Now here you see that we have these kind of things even in our code editors, Visual Studio Code, right? Now here, if you can see these tools, these kind of things, that means all this interface or this IDE is the host, or it simply is the AI capable application, AI integrated application. Any system which has an AI, we can think of as a host, right? So this host is equivalent to an agent. So this is the agent, this box. Now we are always talking about agents. Now this host is similar to an agent, right? Now, uh, now this server, when it comes to server, this is like the environment. Now we are coming from now, even in our previous examples here, this is the host. That server part is the environment, right? There's a small difference, but we will come to that. But you can easily think what when someone talk about MCP, the MCP host is the agent. The MCP server acts as the environment because an agent or the host will do actions on this environment. So when it comes to MCP, it's the server and the MCP app host observes things from the MCP server. Now, left hand side is the MCP host, right hand side is the MCP server. So when somebody talks about MCP server, it's the environment. It's where the agent performs actions, and it's the place where agents get observations or states from the environment. So the server part is the environment, the host part is the agent, right? So now let's assume we are talking about, when we talk about host, our cloud desktop, right? Or any AI application that you are developing, any application. For now, for simplicity, explain you through this host or this cloud application, which is synonymous to an AI agent, right? So that's why here I have entered an AI application /agent powered by an LLM. So all of these are powered by LLMs. Almost all these AI applications or language understandable AI applications now power a LLM, right? Powered by an LLM. Now there is this client part in an host or an AI application that you need to develop, right? Now in this case, when it comes to Cloud Desktop, this client part is already built in. They have developed, right? They have developed this client part already into this host or this application. A client is nothing but making the communication with the server. It's a very small component in MCP ecosystem which sits within the host. It's in the host. Its only job is to open a communication channel, a way to communicate with server. That's all. When people say MCP clients, it's actually the communication part of the host, right? Host is the whole application. This whole application client is the part which it's um, I'm share. You can see the cloud thing, right? What I'm showing here. I'm not sure if I'm sharing the whole presentation or the whole screen. Anybody? You can see this cloud desktop or you can't.
Yes, sir, we can see that.
All right. Okay. I was just double checking. All right. So now this whole application is the whole interface and everything is the host. A client is it sits somewhere within this one, which does the communication with the server. All right. Now I said that now server is the most important part here when you come when you are developing applications or MCP, almost about 70% or 70 to 80% of the time you just have to develop an MCP server, right? What is an MCP server? It is equivalent to the environment in the agent terminology, right? Now, I said that host or the AI agent, this is the AI agent, it can perform actions on the server. Now, to perform actions, the server provides the tools. Now, this is the only part it deviates very small from the original agent concept. Now, assume it like this, right? Now, there is an agent. Let's assume now this server is the environment, but based on the environment, the actions that agent can take differs. Now, for an example, let's assume there is a I don't know, a multi-purpose agent, and humanoid robot. Let's assume a humanoid robot where we tell him we take him and place him in a farm, right? So then in within the farm, the actions that it can take is different than when he is in the road, right? In the road he can't I mean manage the animals and manage the farm activities are different. So server is the environment, yes, but there can be different environments, right? Based on the environment, the actions or the tools. Now here in the MCP terminology, we call the tools. These actions are equivalent to tools in MCP terminology. The tools are different or the actions are different based on the environment. So there is this agent based on the server or the environment, the actions that it can do is different. Right? I think you can understand that. The actions that a humanoid agent can do while he is driving a vehicle is different than the actions that he can perform in a farm, right? Because the environment is different. So like that, based on the environment or based on the MCP server that this agent connects to, the things that it can perform is different. Now, yes, now we talked about that server is the environment and an agent can perform actions on the server or to the server, right? Now, other than that, we know that an agent should be able to observe things, right? Okay, that's why this resource thing, the concept of resources are here in the server, right? he can do an action to the server, and also it can view the server status, or it can get observations from the server, right? Now that is this resources concept comes in. Now, when people actually develop after executing a tool, right, after doing some action, executing some tool, the result also will be passed as the observation to this client, right? Now, it must not be through resources that it should observe things. Even after executing some tool or after executing some action, it can as a response, it will get these observations to this AI application. All right. Now I said that, okay, there are based on the server, based on the environment, server is environment, based on the environment, actions are different. Now, an agent, host is the agent, an agent can connect to multiple servers, right? That is like an humanoid robot can work in road as well. It can work in a farm. It can work in your home as well. So that means a single agent can connect to multiple servers. That's not a problem. It's not a must to an agent to be connected only to a one server, right? Because the world is so much, I mean, it's huge. So there can be various capabilities that the world offers, right? Now that's why this MCP concept is very powerful. So if you develop a simple agent, and if there is these through these servers, and we can provide these agents new capabilities. Now we just need to build an MCP server that with new capabilities that this agent can perform, right? We just build the agent once, and we can build various capabilities as servers or as environments. Now this server might be capable of handling calendar events, accessing calendar in our previous example, right? Another server might be capable of handling the Gmail, right? There's another server, MCP server, and environment that the any agent can connect and read emails, write emails. So there can be a different server to handle these email capabilities. So an agent just need to connect to that particular server and perform those email specific actions or activities. So there might be another server which can access Google Drive. So it can access, get the observe the files in the Google Drive, and or it can create using a tool. It can write new files or upload images, something like that, to the drive. So we just need to build the environment or the server with various capabilities that any agent can act, right? Like that now, even today, there are millions of MCP servers already built. So there are so many MCP servers that can, I mean, for Gmail handling, for Google Drive handling, for Google Maps, uh, maybe for weather APIs, uh, like that. There are millions and millions of MCP servers right now today that can that provides agents various capabilities. Right now, interesting thing is now here the action space is constant. Once we build an AI agent in as in earlier days, so when we were learning, while when we were studying in universities, when we build an agent, the action space for him is constant. It's only the what we defined, right? But now this action space is dynamic. So it can easily connect to an MCP server and get all the new capabilities. It can maybe that server may be providing, okay, new Sinhala songs as well, right? You can just generate an MCP server, create an MCP server that provides for this agent Sinhala songs or Tamil songs like that. So then it will know now new capabilities or new actions will come to this agent, right? So now this table is going to be dynamic from now on with this MCP concept. Now these agents are capable of doing so many things. Action space is now very vast and it's dynamic because of this MCP servers. And same for the state as well. Based on the number of MCP servers that it can connect to, he can observe so many different things, right? There can be so many different servers that it can connect and observe various things. So even this state space, this state set of states is also now dynamic. It's varying. He can increase the observability, the things that he can observe. So with MCP concept, now even these AI agents are now very powerful. That's why this is so powerful a protocol or a technology, and that's why people are talking about this very hugely as a very, very weighted subject, right? Now, with this illustration, we can think of this host plus client is our agent, right? And the server act as the, in our previous example, environment, and this server provides new agent capabilities, new actions that the agent can do, right? Now let's look at an example, right? Uh, yes. All right. Now let's look at an example scenario. An agent. Now assume now this host is our cloud, right? A cloud desktop. That's our application. This one. A user comes in and I ask, okay, about the temperature of Colombo. Can you tell me the temperature of Colombo right now, right? Something like that. Now this one, it does not know how to do it, but for Sri Lanka, it does not know. But now I have built a MCP server. You can easily see this weather server, but it does not know about this Colombo, any United States city. If we can give, it will provide the right now temperature information, that because that the API that I have connected to. Anyway, now if assume we are going to ask something like that, and you have created an MCP server that can access Colombo's or Sri Lanka's weather right now, right? So if there's no such MCP server, if we just ask something like this in ChatGPT, it will not know, right? Right now the ChatGPT interface knows because it can access internet and get information. But if it can't access the internet without that capability, it will not know. Now, if not, assume you need, if I ask something like, okay, what's the overall GPA of University of Kelaniya in this faculty? All right. Okay. Or if I ask something like, okay, what's the, now these ideas that I'm giving are really cool project ideas, right? You can build MCP servers for these things that I'm saying. So if I'm asking, okay, what's the Kelaniya University's number of students for this year? All right. Something like that. If I ask from ChatGPT, it will not know how to answer, right? So you can build an MCP server for Kelaniya University or whatever the university that you are sitting, right? Or whatever the organization that you are in. You can build custom these kind of MCP servers very easily. We will look at an example quickly after this. Uh, but that's the power of MCPs. So we can ask anything from Cloud or ChatGPT. If you have built that MCP server and connected to the ChatGPT or this Cloud desktop or any uh, host, an AI host, any application, now they can access and those information and get answers, right? All right, now let's assume this host is now that the Cloud desktop or any AI application that you have built, you are asking about the temperature of column. Okay, now here the first step is user is asking, okay, what is the temperature of Colombo? All right, now the AI application or the agent gets it, this query, right? Then what it does is it says that our LLM, now any AI application will be powered by an LLM, right? This LLM can be a hosted LLM, that means we may be using ChatGPT or Gemini, those kind of things over an API, or it may be a locally hosted one as well. It's not a problem. All right, first it asks, okay, what's this question? What's the temperature of Colombo? Then what it does is it sends this question to the LLM, right? Because if the LLM can easily answer for that question, then we can easily send it to this user. But now this question, it does not know, the LLM does not know this, it's training or based on the trainings of his data, it does not know the current world, state of the current world, right? So it asks this question, we forward this question to our LLM, and LLM says, okay, I don't know about the temperature of Colombo, I have no idea. Can you tell me that then this LLM says, okay, can you tell me what are your capabilities? You are an agent, you are an intelligent agent, or this, if we can think even all of this as the agent, then what agent thinks, okay, what are the things that I know? What are the capabilities that I know? All right. Then it looked at how many clients do I know? How many clients are there within me? And now since this LLM ask about, okay, what are your capabilities or what are your external tools, things that you have connected to, can you please tell me? So then what it does is, as the number 4 step, through this client, it connects to an MCP server and get all the capabilities. Okay, yeah, from the fourth step, it goes to this temperature MCP server and gets these as number 5. Okay, there is this tool called get temperature tool, and there is this another resource called temperature knowledge documents, those kind of things. There are these kind of things like that. It provides, it gets all the capabilities and observations from this MCP server. Similarly, since it has connected to another MCP server, maybe this is regarding Sri Lankan buses, something like that, right? Another set of capabilities that this agent can through these MCP servers, these different environments. Okay, there's another MCP server that can handle or that know of Sri Lanka bus times or bus things. So now there through this MCP server, it can book bus tickets. And there is this another observation or resource that is provided by this MCP server about Sri Lanka bus routes, right? Here spelling is wrong. Anyway, cell bus routes. It can these set of informations and capabilities are there through this environment. Now, that's why here now number 4 and 5 are similar. Now, this what this host asked or this LLM asked is, can you tell me what are the capabilities that you have? What are the actions that you can perform? Right? To get those, what are the actions that I can perform? It checks all the servers that it has connected to and get those information. All right. All right. Now with through client 1 and client 2, now it knows about these two MCP servers and the capabilities provided by these environments and the observations are all four are now here. After this is fifth step from all of these. And then it sends these information back to as the number step 6 to the LLM. Okay, now the original question is what's the temperature of Colombo? And I know things about an MCP server. There's an MCP server to temperature. There's another MCP server regarding buses. Now all this information after step number 5, it sends to LLM. Okay, here are the capabilities that I know, and here are the observations that I can do. All right, then what LLM does is it checks the question. Okay, the question is regarding temperature of Colombo, right? Okay, in that case, there's no point I am invoking these bus related tools or resources. It says that through this seventh step, seventh response, okay, no, don't think about this, don't even consider these bus things, just use these capabilities. This tool get temperature, use the temperature MCP server and just invoke that one. It says through the step number 7. Okay, with that now, this host, what it does is, as the step 8, it invokes the activity or the action to get the temperature. through this MCP server, it provides an action, new capability for this agent to get temperature of a given city, right? All right, now through this one, now there can be external systems or APIs, those kind of things that this MCP connects to. That's a different thing. But when we are building this MCP server, we have to maybe use existing services or APIs, right? Somehow, now this get temperature tool gets invoked as the step 8, and it as the step 9, now it provides the temperature. Now after step 9, we directly don't send it to the user, right? Now we know the answer, yes, but with this answer we again provide as the step 10 to the LLM. Now this part after 10 and 11, it's more like a rag, right? This augmenting part, we are just getting the answer. Now we know the answer, we are just again anyway sending that answer to the LLM. Okay, I invoked that capability, I did an action to get the temperature, and I got the result, and here's the result that I received. And then LLM checks, okay, is that this is kind of a reasonable, correct kind of an answer, and then it might be augmenting that answer a little bit to a user-friendly manner, and sends that augmented answer as the step number 11. After that, this host can provide that augmented answer to the user. All right. Now this is the whole journey of MCP, right? That it takes on. Now assume you build now here this single AI agent. Earlier, it does not know about temperatures. It does not know buses. Now, if a user says, okay, I want to book a bus from Colombo to maybe Kurunegala or maybe Jaffna, something like that. I want to book a bus ride tomorrow around 8:30 for Jaffna. Then it will invoke this bus MCP server. Now, due to this bus MCP server, it has this capability, right? So what MCP really brings is, it's all about providing context to AI applications. Now, AI applications are what? These host or AI agents, right? This AI application is nothing but this part of the agent. So MCP is all about providing context. Now that's what this meaning. Model context protocol. Model is the agent. All right. That's where our model is here. Here, this is the model. We are providing context for this model. That's the protocol, model context protocol. So what are the context? Context are new environment informations. So in this case, new environment informations are maybe temperatures and also new capabilities to agents. Now model is the agent, OAI application is the agent. So with this MCP, it can now receive new capabilities to get a temperature, to book a ride, maybe like that. You can create so many MCP servers, and even you can host them as well. Now, for an example, in Hugging Face, there is a place where you can host your MCP servers. So it's very easy and it's very popular now. So many people are hosting they created MCP servers in Hugging Face. Then everyone in the world can use them, right? It's a very interesting thing to do. So I invite you to create MCP servers, maybe a very small MCP servers like the previous example that I gave. You can create an MCP server your particular university or particular batch, something like that. Through that, you just create it so that it provides these tools, information, something like that. Then any MCP client or Cloud, something like that, you can easily say open the Cloud application and easily uh, uh, invoke that particular MCP server that you created, right? Through this, now then you can do so many things. All right. So now quickly let me go through this one. Now I said that since it's almost 8:10, I said that now here these clients is just to make this communication thing happen, right? Now this is something that it's better if you know how this communication happens. Now we are talking about a protocol. A protocol is, now you might know about protocols like HTTP, right? Hypertext Transfer Protocol. That's how the web applications work. That's the protocol that they use. Like that, there are so many protocols. Now even this MCP, the last word is protocol, right? So here, for MCPs, we are using a protocol called JSON RPC to communicate. So don't think extensively on this, but this is a good to know thing when you are talking about MCPs. Now, this JSON RPC is it's something like executing functions in a different system. Now, that's what we are doing, right? We are executing a function, we are invoking a function or doing a function which is in a different system. This MCP server sits in maybe in another server, maybe hosted somewhere. Your application might be running on your phone or your laptop. So what does this host or this LLM or this agent do is it invokes these functions or activities which are in a different location. That's all it does. So that's why we use this JSON RPC, which is called a remote procedure calls. RPC means, but we use JSON for this, right? Now, this is a very simple protocol. We use JSON to pass messages, pass information between these two systems. Now, if this is the AI agent, if this is the MCP server or the environment, so all these messages, information is passed as JSON messages like this. So, for an example, a request from a client or an MCP agent to the server would look like this. Okay, now the AI agent might say, okay, invoke, I need to invoke your subtract, a tool called subtract, and as parameters, I am providing this. And there's this ID that we need to send. So that we know that when the response comes in, the response is related to this request that I sent, right? So these are the structures, the message formats that is used in JSON RPC, right? All right. Now here there is this a table that I inserted to differentiate between HTTP and JSON. Yeah. So the main focus here is that if we think about HTTP, it's talk about resources. But in JSON, we are talking about methods or the actions that we can do. So that's the main difference that you need to see this MCP protocol, right? When we are building HTTP systems, so applications which transport messages through HTTP protocol, we are talking about resources there. But in the MCP world, we are always thinking about methods. Right now, there is this. So I'll share this slide set, then you can actually go through and get a good understanding. But since we are almost time, I'll pass through this. Another important thing is that you need to note that MCP, this communication between client and server, it can be, since it is transport agnostic, we can transport these JSON RPC messages over HTTP, even WebSockets as a TCP network, or even locally IO as well, input output operations in local through local processes as well. You can do it. Now, don't think about this message thing very extensively, but it's good to know when you are building MCP servers and applications, right? Now, let's see how we can build a MCP full MCP application very quickly. Let me walk through it since we don't have the full time to build it, right? So here, first thing is we can use this radio I think sometimes some of you may know about Gradio. It's a very lightweight Python framework that we can use for machine learning, right? We can easily expose our machine learning models to Gradio. So we can now Gradio supports this MCP protocol as well. That means it supports this MCP messages, right? Now all you need to do is you can now, for an example, now I created an MCP server that can send emails, right? Now you just need to do what you need to do is you can create a folder, you can go into it, and then you can I normally recommend you to use UV as the package management for these new Python developments because it's very easy and fast. UV. So we can initiate a virtual environment. We can basically initialize the project, and then we can create a virtual environment, and then we can activate this virtual environment using which was created here. And then we just need to add the package UV, right? Now, another step before doing this email server, now with this email senders MCP server, we can just say, okay, send an email to this email address. We can simply type it and it will send an email to the relevant the email. But to do that, if you are using Google, you have to do this one, right? You just need to go to your Google account and open the security and generate an app password. I'm not going to show it because it reveals my app password. So you just need to go to here, app password, and create an app password. All right. So in the code, you should put that app password in your env file, right? .env file. So you can paste that, and then you can access that app password in your MCP server code, right? Now this is the MCP server. Now look, it only has taken me only around 80 lines of code to build an MCP server, full MCP server that can generate or that can send emails to any email address. We just need to say, okay, even in here, if I haven't configured it here, but I can say, okay, send an email to abc at gmail.com saying this like that, and if I type it and send it, it will go. But anyway, I have to configure, right? Now configuring is nothing but we have to say, it's to our clients, our host, okay, there is this client. We have to create a new client in our AI application, right? That's what configuration is. So after that, you can, follow these steps, and then you can create a file called app.py as I have done here. Here, this app.py. Why app.py? Because, especially the name app.py, if you want to host this MCP server in Hugging Face, right? Now you can host this MCP server in Hugging Face. Hugging Face needs its MCP server names to be app.py. That's why. So it's better if you can use that app.py. But if you are testing this locally, no matter, it's okay to use any name. But if you have plans in publishing your MCP servers in Hugging Face, it's better to name the file as app.py, right? Now, when writing an MCP server with Gradio, especially Gradio, uh, it treats, we can say here at the end, MCP server. If we assigns it as MCP server true, all the functions that we write in this file becomes a tool. Now we know that MCP servers have tools, right? Now here we talked about an MCP server can have tools, resources, prompts, sampling, those kind of things are there. Tools are the actions that an AI agent can perform. So when we are writing an MCP server, so we are writing these tools as functions. That's all. Nothing any magic right there. So we just need to define a function called send mail. Some descriptive name is good. The only thing is the input parameters. Now we call these input parameters, right, to the function. So all these input parameters should have these type hints. Now send, what is send email? It's a string. What is recipient email? Okay, it's also going to be a string. Subject is an string, message is an string. Now this function will return a dictionary. Why a dictionary? Now remember that MCP supports JSON as the request and response formats, right? So it's easy if we can return it. It's better if we return it as a dictionary because it's easier to convert these dictionaries to JSON very easily. The only thing is now when you are building MCP servers, you have to define a function which will map as a tool, and then another thing is you have to have these doc strings. Now describing this function, because this is with this, the LLM can identify what does this tool do, what are the capabilities of this tool, because ultimately the LLM will be the one that is deciding, okay, should I use this tool or not, right? To support that, we have to describe this function. Okay, this is this what this function is, or what this tool is. It's an sending email to the recipient from the sender email with the subject and message given, something like that. Some description is there, and then we can inform about the arguments and return things. Now this doc string is a must, but you can write in various format, but it's a must to have a doc string explaining about this function or the tool, and it's a must to have these type hints as well in for all these parameters, right? Then we just need to implement our function, right? Now these are not very difficult things. You can use ChatGPT or anything to say, okay, write a function that sends email to this sender email from this email with this subject and containing this message. You can just simply write it. Now here these are some validations, and then you can uh, with the app password that we configured, we can try to send a mail, right? Here, send message. Now it's supported by this email, which is an inbuilt package for Python. We can easily use that and send emails, right? So this implementing the whatever the function is not that hard. It's just doing the what you are intended to do, right? The nice thing is the important things are these doc strings and type hints. So after that, we just need to launch our app. Now here I have launched it. Let me launch it again. Right. So I can launch it here. UV something like UV run app.py. We can just run our app.py. So what it does is it runs the MCP server, right? So let's see. All right, now it started. Now here we have with this Gradio, we have a interface as well. So if I open it, let me open it. All right, now this is the interface that we created, right? Now, nice thing is I specifically did not create like React, those kind of things to have these input fields, those kind of things. That's the nice thing with Gradio. Easily it provides us an interface looking at our code, right? Now, how did Gradio knew about those things? Now here, I just have to say for Gradio, the GR is the Gradio. There's this text box for send the email like this. I just have to provide set of inputs, and as an output this, and a title like this. Or I just need to provide this set of things. By looking at those things, it created this nice UI automatically, right? Now here, if I send like my email, uh, recipient to email also, let me provide it the same. Testing MCP servers and some content goes here. Test something like that, right? Then what I can do is I can before sending, okay, let's first submit it. So then what happens is it runs. Okay, we are getting a status now. See, it's again JSON, right? The format is JSON. It's success, email sent successfully to say. So if I go to my email, this is the earlier one. I need to refresh it. Now here, this is the email that I got received, right? Some content goes here, test here. So now that means the MCP server works, but how I interacted, how I invoked it is not the, I mean, full MCP way, right? I just invoked it through the Gradio interface, right? It's not the way to, I mean, we can do that, but it's not the way to invoke MCP servers, because MCP servers we are normally invoking through AI applications or cloud kind of a desktop kind of a thing. Now to wire this MCP server to our cloud, now we have to configure, right? Because you know that any AI host needs to have a client component within that. In our presentation, we saw that now a client needs to be there. Host is our MC cloud desktop or cloud application. Now we have to configure a connection. We have to configure a connection. We have to create a client. To do that, now we have to provide this MCP connection details to uh, our host, right? Now to find those, you can use, if you are building, if you have built it using Gradio, you can click on this use via API or MCP here. So you can click that, and now if you are to use this through Python or curl something, these are also possible. But now this is the interesting part as an MCP client, right? Now all you need to do is to make this available to whatever the AI application or AI agent. You just need to provide this set of configurations in there, right? MCP server, this is the Gradio. My MCP server is located here. That's all, right? Now this SSC is another interesting thing, now the communication protocols, but let's not go through that since the time limitation. All you need to do is now get this JSON string and add it to Cloud desktop, or not just Cloud, even for IntelliJ or VS Code, anywhere. Let me show you the VS Code. Now here in VS Code, now you can see here, select tools, right? Now here we can add more tools and add MCP server here in Visual Studio Code. And then we can add something like npm package. Yeah, I need to update, I think, my VS Code, but it's very easy to add MCP servers. Uh, yes. Through here, add MCP servers. There are various options. We can add our MCP server as an npm package, a pip package, or we can even we can create our MCP server and put it in our one of our Docker images and use it there, right? Or we can use this as well. So we just need to provide here our MCP server URL, which we copied earlier. Let's see. Okay, it did not copy it. This is the URL. So we just need to provide it here, right? All right. Now it's let's see if it has accepted. I may need to refresh it. Okay, let's see. Yes, trust. So now it's updating the available tools or MCP servers for this client. Now this is our agent or the MCP host. If we are talking about MCP terminology, or simply we can think of it as an AI agent, right? Now here I have this MCP server Gradio that I created. Now it's now available. Send an email to a recipient from the sender email. So if I type here, now I'm here trying out from IDE first time. I'm not sure if it's working. Send an email from Ashan Priyadarshana at gmail.com to again to that one to Ashan Priyadarshana. The subject is hi from VS Code. The message is hi from something like Copilot. I'm not sure if this works, but let's see. So I'll help you send an email. Let's ready. Okay, it now here. I'll help you send an email using email send application. Let me run the Gradio interface and use it to send the email with you. Okay, now it identified. Now this host identified there's this new capability that I can. There's a MCP server, and let's see if I can continue. All right, now there's an error, maybe some configuration error. Let me check the output. Yeah, now it keeps on trying, but since I did not configure the correct path, oh no, now it, I think, all right, seems like, yeah, let's continue. All right, so it says that email sent successfully. Let's verify that. So yeah, I'm also doing this for the first time using IntelliJ. Let me see. All right, yeah, it has come. Hi from VS Code. Hi from Copilot, something like that. It has received. So it's a nice capability. Now you witnessed that we can how this interoperability feature is coming through MCP protocols. Now we just sent an email uh, to my email. Or basically we can send emails from IDE, our coding thing. So we can just get a copy of our code and send to your friend, right? I can easily do that. Okay, send these codes to this email address. Now that capability is there for VS Code, right? So that's the power of MCP. I hope at least you understood what's MCP, what are agents, and why this is a really important thing that you need to be aware of when you are going to develop applications, right? So I think with that we can wind off. It's 8:33. I think yeah. So over to you, Vindya. Yeah.
Thank you, Mr. Ashan Priyadarshana, for your insightful session. Your knowledge and experience are truly valuable, and we are truly grateful for the time and effort you have taken to share your expertise with us today. It's been an absolute privilege to have you with us. Dear sir, please accept our humble token of appreciation.
Yeah, sure. Thanks, Vindya. All right. Yeah, thanks.
If you have any questions or anything for Mr. Ashan Priyadarshana, feel free to ask. You can unmute your microphones or drop them in the chat.
Seems no, right, Vinder? I think we can. So if you have any questions, just reach me. I think you know my mobile number. Okay. There's one question. So in the example you explained, host is the GitHub Copilot, right? Yes, the host is the GitHub Copilot here in this case. So at least I can, I mean, be happy that you have understood correctly, right?
As we nearly end of this remarkable event, I would like to invite Pubudu Madhushan, the University representative of AI-driven Sri Lanka, to deliver the vote of thanks.
Am I audible?
Yes.
Thank you, sir. Good evening, everyone. It's truly an honor and privilege for me to deliver the vote of thanks on behalf of the organizing committee of AI-driven community. First and foremost, I would like to extend my heartfelt gratitude to our esteemed resource person, Mr. Ashan Priyadarshana, for taking the time to share such valuable insight with us. Your session focused on the practical implementation of AI was not inspired, but also incredibly practical. And thank you to the AI-driven organizing committee members for their continuous support and collaboration. Your contribution have been valuable in making this event a success. And special thanks to our organizing committee and coordinators who worked tirelessly behind the scene to ensure the smooth execution of this session. Dedication and commitments are deeply appreciated. And lastly, to all our participants, thank you for your enthusiastic involvement. It's your presence and engagement that made this session meaningful. Once again, thank you all for being part of the fruitful session. Have a wonderful day. Vinya?
All right.
Thank you. Before we officially end the session, we would love to take a quick group photo to capture this moment together. So kindly turn in your cameras and don't forget to set the virtual background that we have just sent in the chat. Let's take a nice screenshot of everyone. We will wait a moment for everyone to get ready. Thank you everyone for your time.
All right, then we can wind up, right?